Measures of position of z-score. Z-score, also called the standard score, represents the number of standard deviations a score is from the mean. Always round value to 2 decimal places. If z-score equal to 0, then data value is the same as the mean. This is formula of z-score. That is value of x minus which mean and divided by standard deviation. This is for sample and this is for population. Another use of z-score can also be used to compare relative position for different data sets. Example 1. A student scored 65 on a calculus test that had a mean of 50 and a standard deviation of 10. She scored 30 on a history test with a mean of 25 and a standard deviation of 5. Compare her relative positions on the two tests. For calculus test, we substitute the value of s, that is 65, and we minus with mean, that is 50, and we divide by standard deviation, that is 10, and we get 1.5. For history test, we substitute the value of s, that is 30, and minus with mean 25, and divide by standard deviation, that is 5, and we got 1.0. From the value of z-score that we got just now, we find that 1.5 is high relative position. Since the z-score for calculus is larger, her relative position in the calculus class is higher than her relative position in the history class. For example 2, find the z-score for each test and state which is higher. For test A, the value of s is 38, mean is 40, and standard deviation is 5. For test B, the value of x is 94, mean is 100, and standard deviation is 10. So we calculate for test A, the formula of z-score, the value of x 38 minus with mean 40 and divide by standard deviation, that is 5, then we got negative 0.4. For test B, we substitute the value of x, that is 94, and we minus with mean, that is 100, and divide by standard deviation, that is 10, then we get negative 0.6 for test B. From the value that we got just now, we find that negative 0.4 is the high relative position. The score for test A is relatively higher than the score for test B.